Hey kids, welcome to another math video. This is for Module 6, Lesson 1. And yay, it's so exciting to be in Module 6. Always exciting to start something new, a new topic. And so just to look at the objective of this lesson, we're going to be constructing a coordinate system on a line. And so if you really want to learn about how to do this, go check out my other video for the problem set. But just to kind of remind you, if you're doing the homework and you haven't seen it, number lines can be counted in any amount and they can go on forever in both directions. So just to review some of the notes that I had in my other video, number lines go on forever in both directions. They can count by any amount. Oftentimes on your activities, you're going to have to identify what the letters are of certain numbers. So you want to look and see, well, what are we counting by and then what's missing. Super fun, super easy, but remember, you can count by any amount. Try to find the zero, try to find the next little tick mark and see what they're counting by. Sometimes it's whole numbers, sometimes it's fractions. I have a few good notes again on the other video. Really important things that you have to know about number lines. Basically, you can find a zero somewhere on the line, but they might not be on your paper. Okay, so all number lines will have a zero. They would typically start with a zero, and for our axes in 5th grade, we're going to have this zero at the origin. They continue forever in both directions. You can count by any unit. And tick marks must be equally distant. So if you're writing your own number line, try to be really precise about counting, like tick, 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 tick. Make sure they're equally distant. Some of our number lines are going to go up. Some lines will go down. Some will count off in positive directions this way. Some will be positive in this way. Zero is called the origin. And in our ordered pairs, X will always come before Y. It goes X, Y. 0, 0 is the origin. Other important notes, here are some sample number lines. They can go from 0 to 10, 0 to 100, counting by tens. They can go up and down. You can start this way. Like I said, it can go to the left in a positive amount. This is going to be the weirdest one, so that might be new for you. Into the homework now. Answer the following questions using number line Q below. So you're going to look at this, and then it starts out nice and easy. Thank you, Eureka math people. What is the coordinate or distance from the origin of the happy face? So if this is our origin, again, starting with that 0, what is the coordinate, the distance, the address, the location? Where does the happy face live? Simple. It lives at 3. What is the coordinate of the lightning bolt? Simple. Look, if this is 3 and this is tick mark 3, then this is going to be a 1, 2, 3. So then that means we're counting by ones. Number your number line, and then you can get out here and see where everything is. That's basically the easiest way to do it. And then we're just looking at whole numbers right now for our points. What is the coordinate of the heart? Easy peasy. 1 below 15 would be 14. And then, what is the coordinate? Here's where they start to make you think. At the midpoint of the lightning bolt and the heart. So now you're going to look here and here and see that this is at 8 and this is at 14. So the midpoint, now you can mathematically do it or you can look at it visually. Okay, now mathematically, you would want to find the difference between these two and then take the halfway point. Okay, so the difference between 14 and 8, you've got your 6. 1, 2, 3, 4, 5, 6. So what's the halfway point? It's going to be half of 6 equals 3, and the halfway point or midpoint would be from here, 1, 2, 3. What is this number? It's going to be 1 before 12, so it's 11. Okay, so sometimes you're going to think, sometimes we're just going to plot points, sometimes we'll just identify shapes. Let's move on, and I'm going to straighten you out there. Use the number lines to answer the questions. Plot T, that means draw it. so that its distance from the origin, this is going to be key, distance from the origin is 10. Distance from the origin, we have to go from 0 and go 10. So what are we counting by? Again, blank, blank, 3, and then you have all these blanks. It looks like we're counting by ones. 1, 2, 3. Makes sense. 4, 5, 6, 7, 8, 9, 10. And so we have to plot it so that we're at 10. Put a point, put the letter so that you've labeled your point. Okay? You can move over here. Plot M so that its distance is 11/4 from the origin. Now here they're checking your fraction knowledge. So 11/4 is what? It's an improper fraction. And so you need to straighten it out because you might not see, 11/4 labeled on here. If you're counting by fourths, it means that this is 1/4, 2/4, 3/4, 4/4. 4/4 is 1, which makes sense because this would be 2 and this is 3. So if you're counting by fourths and we need the 11th fourth, straighten that out into a proper fraction. 12/4 would be 3, so 11/4 is this last one. It's actually 2 3/4, which is right here. And we're going to call that M. Okay, you can put it above or below, it doesn't really matter. The next question is, what is the distance from P to M? So some kids will say, I just want to count it. From here, you don't count the one you're on, you count when you go away. So 1, 2, 3, 4, 5, 6. 6 hops, but the distance isn't 6. Okay, so you have to look at how many units you have and what you're counting by. We're counting by fourths. Write that down so that you can count properly. So from here to here, it would be a distance of 1/4, 2/4, 3/4, 4/4, which is 1, and then 1 1/4, 1 2/4, or 1 1/2 is your actual distance there. Okay? 1 2/4 is okay. It's just not the best answer. Okay? Hopefully that's coming along for you. The next one says plot a point so that it is, okay, we have an amount closer to the origin than Z. Here is where in the notes I said every number line has a 0. Well, you're saying, you look at this and you go, well, there's no 0 on this number line. And I'm telling you that somewhere along the line, there is a 0. You have to figure out which direction it's going to be in because some number lines are going to go this way and some will go this way. So which is the larger number of these two? That's what you have to think about. Okay, if this is 75/100ths, make a fraction out of it so you can think. And this is, ooh, what? Do you have any hundredths? You have 100 hundredths. Okay, so this one is where the number is getting larger, and this way is where we're getting smaller. So 0 is out this way. Okay, smaller, larger. Now I need to, sorry, not that one. Plot a point that is 15 hundredths closer to the origin than Z. So if this is Z, and I have to go closer to the origin, that's this way. So now I know which direction I'm going, and I have to calculate 15 hundredths. What are they counting by on this number line? If I have 75 hundredths, and then I have tick, 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 I have 5 tick marks between 75 and 100, you could say, all right, I think they're counting by 5s or 5 hundredths. So 80, 85, 90, 95. And then you have filled in the values, counting the right way, making it bigger this way. Now you have to go from Z and go 15 hundredths, which is, each one of them is 5. So it's going to be 5, 10, 15. Okay, so you want to plot your point at what would be 80 hundredths or the one just to the left of the 75/100ths. Okay, I hope this is helpful. If you find this video helpful, do click subscribe and come back again. Here's the next one. Plot U so that its distance, U, from the origin, again, we've got to figure out where it is 3/6 less than that of W. Another way of saying 3/6 is 1/2 if 6 is not being used, but it is being used. So we can leave it at 3/6 for a minute. Let's take a look at what our numbers say. We've got a 9. We've got a 10 way down here. We've got a bunch of tick marks in between. This one's labeled 2. Would it make sense to count by sixths? 1/6, 2/6, 3, 4, 5, yep, 6/6. So these little tick marks are all 1/6 apart. So this would be 9 and 1/6. This would be 9 and 3/6, 9 and 4/6, 9 and 5/6. You can label it so that you understand what you're doing. Now we have to plot a point, okay, so that its distance from the origin is going to be up here where the numbers get smaller, so 10, 9, 8, 7, off in that direction, okay. Distance from the origin is 3/6 less than that of W. 3/6 less is going to be going toward the origin, and we're going to count 3/6. If this is 1/6, 2, 3. Plot a point, label it U. A lot going on there. There is a lot going on here. This is U right there. Okay? Let's turn the page. Okay, a bit more on the back. It's all good. You guys are going to love this. Okay, number line K shows 12 units. Now, again, look at the holes are the 12 units, which means everything isn't labeled. So if you would like to put in the odd numbers, now noticing that these are all even, where would the odds be? It appears that they're counting by halves, because if this is 0 and we go skip, skip, skip 2, then this would be 1. Okay, skip, or 1.5, 2, 2.5, 3, 3.5, 4. And so every other tick mark is going to be where the ones are, because they're counting by half units. There you go. Now do that first so it'll keep you on track. First one, plot a point at 1, label it A. Okay, well, since you just labeled, plot your point and label it A. Check it off when you do it. It'll help keep you on track. Label a point that lies at 3.5 as B. Okay, again, if you labeled it, you should have 3 here between the 2 and the 4, but we need 3.5, which is going to be between the 3 and the 4. Okay, so this point you're going to plot at 3.5, and we're going to call it B. Okay, so we've got between 2 and 4 we have 3, and between 3 and 4 we have 3.5. Check. And for C, label a point C, how lovely, whose distance from 0, here's where you have to think, is 8 units farther than that of B. Okay, you go to B, and we have to go 8 units farther, 8 whole units farther than that of B. And we're going to label that point C, and it has to be actually 8. Okay, so 1, this is half, this is 1, 2, 3, 4, 5, and we're going 8 units, 6, 7, 8. Okay, so when you count 8 whole units, it's not 8 tick marks, it's 8 ones. And every one is every other. So you're going to skip 2, okay? Skip 1 to 2, get to 2, get to 2. And then you put this point right here, and we're going to label it C, right there. And the coordinate of C is, what would you call that? Between 11 and 12. That's right. 11 and a half. Okay, done. Plot a point D whose distance from 0, zero's over here, is 6/2 less than that of B. Okay, now you have to think again. You have to make sure the lights go on. Woo! You have to think again about what is 6/2. Well, 6/2 is just 6 divided by 2 for 3. So it's going to be 3 less than that of B. Where's B? B is right here. We're going to plot D, whose distance from 0 is 3 less than B. That's going to go here. 1, 2, 3. Plot your point at literally only that half. Okay? The coordinate of D is 1/2. Okay, next one. What is the coordinate of the point that lies? Love these improper fractions. You get to straighten things out. The point that lies 17/2 farther from the origin than D. So we did not label. Maybe you did. I hope you did. I didn't, but now it is labeled. We have our point D because now we have to use it. And we're going to find the point that is 17/2. Let's straighten that out so we can see in whole numbers. It'll help us get down here where we have to go. So 17 divided by 2 is what? 8.5, because 16 divided by 2 would be 8 exactly. So we're going to go 8.5 units farther from the origin than D. We're not going to start at the origin. We're going to start at D. And you're going to go 8.5 units. Now again, it's going to be skipping just the opposite direction down what I've already done. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, and then a half. That's only going to be one little tick mark. Okay, and you're going to label it right here. Almost lost track there. I took my eyes off it for a quick sec. E. Okay, label it E. And so that one should be right at 0.9, or 9 on the number line. Done. What is the coordinate of the point that lies halfway between F and D? Here's F and here's D. They're pretty far apart. So again, what are we at? We're at 9.5 and a half. So kind of like on the other side, if you want to find the difference between the two, then you have to literally subtract. So 9.5 minus a half equals 9. And so what's half of 9? It's, okay, 4.5. I'm just going to tell you that. Okay, 4 plus 4 is 8, 5 plus 5 is 10, so you have to have half of 9, which is an odd number, so 4.5. So if I need to put that on the number line, label this point G, that's going to be our halfway point. One halfway point between F and D. Let's do that. 1, 2, 3, 4.5. Okay, I just started at 9, but you can start at D as well. It would be exactly in between. And again, watch, I just went 1, 2, 3, 4. Sorry, I think I started the wrong one. I did. Get a different eraser so I don't kill this little baby one. Now you can have the right answer. I was like, I didn't land at the right place. 1, 2, 3, 4.5. There it is. All right, that's from F, not E, from F. Okay, so you're going to be at 4 and, sorry, you're not at 4.5. It's 4.5 of a distance, but you should be at 5, and that is going to be G. That's about as clear as mud. Sorry, I'm glad that we had a chance to fix it, and make sure you fix it. You're leaving from F, and you're going down 4.5 units, and you will end up at 5. Love that. Check, done. Okay, now finally, last one. Mr. Baker's 5th grade class buried a time capsule in the field behind the school. They drew a map and marked the location of the capsule with an X so that his class can dig it up in 10 years. I'm sure it'll be in great shape. What could Mr. Baker's class have done to make the capsule easier to find? Okay, so the whole idea, remember the objective right down here at the bottom, is to construct a coordinate system on the line. You could literally write that, okay? Construct a coordinate system on a line. That would totally work. What you want to include is that you need to have a number line, okay? You have to count so that everybody, there's a standard measurement so everybody could follow it. If you use coordinates, you're going to have more than just one thing. If it's just an X out in the middle, you could be coming from any direction. So use specific measurements. Okay, so you want to count by something. You want to do what the objective says and use coordinates. Okay, so that's going to be between two directions. Okay, so if I'm going to leave the school, I'm going to go out this way. Well, it's also going to be a distance from the playground, or it's also going to be a distance from the fence of the baseball diamond, or whatever it is. And it's always good to have an origin. And those are very important things when using a graph or a coordinate system on a line. I hope this helps you, and come on back again for another video. We'll see you on the next one. Bye for now.